Alright, in this video, I'm going to basically, instead of looking at the decision tree visual representation and trying to choose what is the best number of leaf, I'm going to create a loop to calculate the accuracy score for the training and validation data sets, and then basically record that information to a table to visually check or find the highest scores and so forth, or just visualize the information itself. Right. So let me start first. I'm going to define a couple of things. One of the things I'm going to define is a range of numbers that I'm going to check for this maximum number of leaf. Right. So I'm going to create. I am creating basically a NumPy array, and this array is going to be between 2 and 51. Again, if I have a single leaf, then basically I haven't done any decision tree. Everything is combined, and based on the proportion of the things, the decision is going to be like majority rule. When I'm creating the array, I'm gonna create basically upper bound +1. So what I'm saying is that when I say MP range 2 to 51, I'm actually creating a range between 2 to 50, right? And I can check that one, right? All right, so as we see it, it is from 2 to 50. The next thing is I'm going to create a table, right? And let me name this one as leaf score. So I'm gonna record the scores, and that is the accuracy score for the training data set and validation data set. I will also keep the number of leaves so that I don't get confused by any means. So this is going to be a Panda data frame this time, right? And the columns are going to be, right, that's a square bracket, number of leaves, right? Of course I need to put these in, right? And then comma, train score, that is the accuracy score for training data set. I could name this as I want, right? And then validation score, that is validation accuracy score, right? And then I am done. I could also similarly look into this leaf score to see what is there initially, and nothing except basically the first columns to show the column names, right? So at this step I can start building a loop, and that loop is going to be a for loop. So I want to iterate through the maximum number of leaves, and I'm using an index of I, and this I is going to be in the leaf range, right? Remember, the leaf range is between 2 to 50, so I'm gonna try all of them, right? And for each maximum number of leaf, I'm gonna build a decision tree model, and that is decision tree classifier. Remember, I used this earlier, and I'm just checking maximum leaf nodes, and this is going to be equal to I. So, and I'm gonna change these I's every time, right? And then I'm gonna, given an I, I'm going to fit my model to this decision tree data, that is X train and Y train, right? Once I fit, then I'm going to calculate the accuracy scores, right? And for that, let me just copy paste, right? And I'm gonna give a name to just make life easier, ACC train, and then ACC validation. Again, I could choose any name I want. This time this is validation, so I'm calculating the validation data. All right. Once these are done, then I'm going to basically score this I number that I just changed, accuracy score for the training and validation data set into this leaf score data frame, right? So I'm gonna say the leaf score this time, right? That is whatever I had as a leaf score, and then I'm going to append, basically add this new line with the following information, right? So, and then open a curly bracket here. I'm going to add the number of leaves. These are all case sensitive, so make sure and that number of leaves is equal to I, right? Then I'm gonna add the train score that I named earlier, and this is going to be ACC train, right? Accuracy score train, and then I have validation, right? And I'm trying to make sure that I'm using the same, capital letters and so forth, because it's a case sensitive result, and then that is equal to ACC validation, right? And then I'm gonna add this line, ignore indexed, right? And once I finish this one, now I should have basically, or let me see, where did I do? I have a mistake. Okay, for I in leaf range, right. So for I in leaf range, I'm gonna do all this and then get this result. Of course, we can always look into the leaf score dot head, right? This is the first 5 rows, and if I want to, I could just say 50 and check all of them, right? What I see here is like 98, 40, kind of the largest number. Of course, initially when I started, about 90% of the data was denied offer, and then about 10% was accept offer. So even with the 2 leaf, I'm about 90%, right? Just increasing to about 11 leaf gets me over 98%, and even at 87, I'm really close to 98%. So, and then it just kind of fluctuates between 98%, 20 and 40, right? But it seems the 98-40 is the largest one. Now that's good, but again, especially when there is not a unique highest number. Oh, 1985, 45 is here, or 55 is here, so it's kind of still difficult, right, for me to see that one. Of course, I can look into the max of this column, like the describe function, right? And then max of these, and kind of find out where the maximums are. But that's something we have done in the past. So I'm gonna try to show you a new thing, that is building or creating a figure, right? And that is basically, I'm gonna do it with the mathplot.lib. Right, if you remember earlier, I included that line to the code right here as PLT, and I'm now using it, right? So I'm gonna plot, and I'm gonna plot number of accuracy score for the training data set and validation data set. So, and these PLT plots are gonna be for each one of them separately, right? So what I'm trying to do is the leaf score, right? And I will have number of leaves, right? And then train score, that was the name I used. All right, of course I need to put it in the brackets, right? And then I can label it I can say the label for this line or is going to be training data, right? And then I could come down and I'm gonna do the same thing, plotting, but this time instead of the train score, I'm gonna add the validation score, right? Valid score, right? Let's do validation data, right? And then let me also add one more preference and say that color is red, right? So I'm gonna add the legends, basically that labels legend, and let's see if it is going to show it, right? Oh, I see it. Leaf score, right? So this is x-axis, leaf score, number of leaves, and this is the y-axis, right? Leaf score, train score, and then leaf score, number of leaves is the x-axis, and then the y-axis, right? This should work. Right, now we have the basically legend, training data, validation data. Again, even at 2, I had like pretty high classification rate, but as I go to about 5, 6, then I get very close to 98%. And once I reach 8, I believe I'm above the 98% for the training data set. And around 10, both of them are above the 98%. Now, as I increase the number of leaves, the training data accuracy score keeps going up until it reaches 1. And if you look into this figure here, you'll see that at 46 leaves, I will have 100% classification accuracy, right? I am still adding more leaves here, but that's like a random cuts. Basically, does not serve any purpose at this point, right? And this is something we discussed in the class as well. With the decision trees, you can get to 100% accuracy with the training data set, given that you add enough number of leaves, right? But what I am interested is not the training data set, but the validation data set itself. Now this figure, let's kind of increase the figure size a little. And to increase the figure size, I'm gonna say figure size is equal to 12 and 8. Hopefully that is big enough. Right, this is better. Right, so this is slightly better to look into it. And looking at this, we see I believe the max is somewhere here. Right, so somewhere 18 to 19, we kind of hit the maximum. But all these numbers are pretty close to each other, right? So it depends on my objective function, what I want to do, right? If I am all about getting the highest accuracy score on the validation data set, then I'm gonna find this point, and I think that's about 18 probably. 17, right? That's 98.55, right? So I will say the best number of maximum leaf is 17, and that gives me the highest, right? Am I missing something? I'm gonna just double check. My astigmatism doesn't help me in this regard, so I need to be like reading the numbers honestly, right? So yeah, that is 17 is the highest point, basically whatever this point is, right? And if I look into the highest and lowest after about 10 or 8, there's not much change over there either, right? And I'm just using this one. Like at 9, I hit the 98% 30, and the highest is 17 with the 98.55. That's like really negligible difference. Now in practice, you may consider basically going with the 9 because it is not very different than the 17 solution, but because it has less number of decision tree or leaves, it might be better for generalization. As you add more and more basically tree leaves, then you are losing that ability, right? And also like even the visualization part, if I add 9 leaf, I would be able to even see on my table here. Let's do it for the sake of it. Our number was very close, 9. Right. Right, so I can still kind of see it with the 9, but 17 is going to be a big challenge to see everything. So that is what it is. So if in practice, if you are doing this for living, you could probably go with the 9. But in the class, as we discussed many times, I want you to choose the number based on the highest accuracy score of the validation data set, right? And that would be 17. Now, as you see here, again, as the number of leaf increases, the gap between them also is increasing. Again, it's not very significant. The worst case scenario is like 1.8% or so, but that tells me that there is overfitting issues, right? Possibly after this point somewhere, I would get suspicious that I'm overfitting the algorithm, right? And that means, again, if there is a third data set, test or production data set, my result could be significantly different than what I see here, right? But for this data set, it is specifically made for this type of analysis. So we get really high accuracy scores, right?